Welcome back from spring break. We are in week 12 and we are also in the week of April 4th. Just a heads up that we are about 2 months, maybe even a little less than 2 months from the end of the school year. So that's something to look forward to. I know sometimes it's hard to come back to school after spring break, but do keep that in mind. That's exciting. And there's lots of fun stuff that happens in spring. So let's keep positive and work hard to finish the school year strong. So we are going to jump into week 12 and think back what we did before spring break and do a little bit of a warm-up to review and get our minds all warmed up. So make sure you've got your calculator out and your math notebook so that you can take good notes as you watch this recording. Remember, you do need to be taking notes. And let's look at the warm-up question where we've got a rectangle and we want to find the area of the rectangle based on the base and height or length and width of this rectangle. So go ahead and click pause and try to complete this work in your math notebook. And then when you're ready to check your work with mine, go ahead and click play. Alrighty, so remember the formula to find area of a rectangle is base times height. So what we need to do here is we're going to multiply these two dimensions together. And really what we're getting is some good algebra practice here with making sure we remember how to distribute, or some people refer to it as foiling. So let's take a look at that because that's an important skill that we need to remember. You're going to use it in your math for years to come, so we want to make sure that we remember how to do this correctly. All right, so the first thing we need to do is take this first term, 4x, and multiply it by the first term in the second set of parentheses, and we get 8x squared. Then we're going to take that first term and multiply it by the second term in the second set of parentheses. 4x times 2 is just 8x. Then we're going to do the same thing. I'm going to get rid of those arrows, and that we're going to do the same thing with that second term in the first set of parentheses. We're going to take 3 and multiply it by 2x, then we get 6x. Then we're going to take 3 and multiply it by 2, and we get 6. Then we are almost done. We just need to combine any like terms. I see that there's 2x terms, so we're going to have 8x squared. We're going to add that 8x plus the 6x, and we're going to get 14x, and then we've just got that constant term. So this is our final answer here. 8x squared plus 14x plus 6. So again, we just want to make sure that we remember how to properly distribute, or you might have learned it as foiling. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. All right, so what are we doing this week? We are going to focus on Unit 7. We're going to continue exploring quadrilaterals. We're going to focus on sessions 5 through 7. And this week is all about volume and surface areas. So we're going to learn how to find the volume and surface areas of a lot of different types of figures. Oh, not only just quadrilaterals. I know I just said that, but that's not true. We're going to look at prisms, cylinders, cones, pyramids, and spheres. So we're going to jump right in and just get a little bit of a reminder of what these shapes are. So cones, you've got a circular base, and pyramids. Pyramids, you can have triangular bases. You can have so you can have triangular, you can have square, you can have rectangle. So pyramids, different types of bases, and we name the pyramid based on the shape of our base. Spheres, here's a picture of a sphere. Prisms, we're going to talk about in a moment here, and cylinders, where we have 2 circular bases. So prisms are pretty wide. There's a lot of variety. So prisms get their names from the shapes they are based on. So they're bases, really. Whatever their bases are, that's what we name them after. So not only do we call prisms prisms, but we get more specific based off of the base. So here you look, there's a lot of different prisms, and look at all the different bases. So they all look different based on their base. So prisms get their names from the shapes they're based on. Prisms have two faces that are the same shape. Those are the bases we just talked about. And then all the other faces are rectangular, or are parallelograms. All right. So examples of prisms. We have a square prism, or we can call it a cube, where the bases are squares. A rectangular prism, where the bases are rectangular. We have cylinder or a circular prism. That's not really, actually, I don't want that one in there. Let's ignore that one. Let's pretend that's not there, because we call those cylinders in this class. Triangular prism, we've got two triangular bases. The rest are parallelograms. We've got a rectangular prism, pentagonal prism, because the bases are pentagons. So just some examples that and really what I want to drive home is that we name our prisms based on those two bases. You're only going to have two sides that will be, in this case, triangles. The rest will be parallelograms. Here you can see that again. These are just two good examples too. We've got five-sided bases, which we called pentagons. So this would be a pentagonal prism. The rest faces are parallelograms or rectangles. So now that you guys know what prisms are and how we name prisms, let's focus on pyramids. You're going to be looking at pyramids as well this week. And pyramids are also named on their base, as I mentioned before. So we can actually have a square pyramid if we have a square base. Other times we might have a triangular pyramid if we have a triangular base. So you can see examples of both of those. Here's a rectangular base. And then we've got several triangular lateral faces that come up and meet in a point that come up from our base. And then with the top is our vertex. So this week you're gonna be looking at how to find the surface area and volume of pyramids. And what's important is that we know what the letters represent in the formula. So the formulas are going to involve the slant height and the height. And I want to make sure we know the difference between both of those. You're going to see slant height and height throughout this week, and it's important that we know what each of those are. So slant height is represented by the letter L, where the height is represented by the letter H. So what's the difference between the two? So here we see the height, and the height starts at the vertex and goes straight down and makes a right angle with the base. So it must, just like we learned in the previous weeks, make a right angle with the base. So you can think of it as somebody dangling a string from the vertex down, straight down from the vertex. That's the height, and it would create a right angle with the base. Where now let's focus on the slant height, and the slant height is the height of the lateral face. So that this slant height here is the height of the lateral face. So again, make sure you write these down, the difference between the two. They're very important because you will see L and H used in the formulas this week, and it's important that you are able to distinguish the slant height right here versus the height. All right, so moving on. click pause if you need more time. So before I go on any further, I mentioned before this week you're going to be focusing on finding the surface area and the volume of all those different figures that we've talked about. We've gone over prisms, pyramids, we looked at cylinders, just the general shapes. I showed you the general shapes of everything. And right back here you're going to find the volume and the surface area of all these different types of figures. So before we go on further and explain how we find the surface area and the volume, I just wanted to quickly review what the difference is between surface area and volume. So we use volume and surface area to describe the measure of space within a three-dimensional figure. And we've seen those three-dimensional figures. So surface area is the measure of the amount of material on the outside of our figure, where volume is the space, the amount of space within our three-dimensional figure. So if we are talking about, let's say, a can of paint, a cylinder of paint, a can of paint, the surface area would be represented by the measure of material made to make the can. It's the metal along the outside. Remember, the surface is the amount of area along the outside of our figure, where the volume in a can of paint would be the actual paint that is used to fill up that can of paint. So that's the difference. Just a quick reminder between surface area and volume. Surface area is the amount on the outside. Volume represents the amount on the inside. All right, so we talked about prisms and how they can be named by their bases. We already did that. So another thing you're going to be, let's focus on prisms right now. Let's focus on prisms and how we find surface area. So we're going to jump right into prisms and how we find the surface area, or the amount on the outside of the prism. So another term you're going to see is lateral area this week. And lateral area is used to find the surface area. So the lateral area is just the area of each lateral face, and then we add those all up. So remember, the lateral faces do not include the bases. So the lateral faces are just those rectangles that connect the bases. That's what our lateral area is we're only talking about our lateral faces. So not including the bases. So we would find the area of each lateral face, add those all up, and that would be our lateral area. So it's the area of all the lateral faces. So remember, our lateral faces does not include our two bases. Aha. All right, so there's two ways that we can find lateral area. The first way is we can find the area of one of our lateral faces and then multiply by the number of lateral faces that we have. Or we can use a formula. So lateral area is P times H. P times H, and that should be a capital P actually. P times H, where P represents the perimeter of the base and H represents the height. So again, it's really important that we know what the variables represent in our formulas. So two different ways. One way is just to find the area of each lateral base and then add those all up, or use this formula where lateral area equals the perimeter of the base. So we actually use the base and then we multiply times the height of the actual, right here's our height of the prism. So let's do that. Let's find the lateral area using both methods that we just talked about. Lateral area, I just gave you a different one, which is going to be lateral area equals the perimeter times the height. So let's use the first method where we're going to find the area of all of our faces. So the area of all of our faces. So we know that we've got this face here, and it mirrors this face in the back. So these two will have the same dimensions. So let's find the area of these faces. Or I'm sorry, the area. So to find the area of a rectangle, we're going to take base times the height. So we know the base is 10 centimeters, and we know the height is 12. From here to here is 12, and the base was 10. So we get 120 centimeters squared. So we know that there's two of those. So we would multiply that by 2 to get 240 centimeters squared for both of those. Now we need to find the sides, the other two sides, which is this side here, and then that mirror image, the same dimensions over here. So that base and that height, we're going to multiply together. Maybe change colors here. What do we have? The base is 6, the height is 12. 6 times 12, we get 72 centimeters squared. And again, there's two faces, lateral faces that have those same dimensions. So 72 times 2 is, 72 times 2 is 144 centimeters squared. So now we need to add our two totals together. So we would add 240 from our first two front faces, lateral faces, plus 144. So what do we get when we add those together? 384 centimeters squared. And remember, this represents the lateral area. We're just talking about the lateral area right now. And then we'll eventually tie that into finding the surface area. So then our other formula is we find the lateral area by taking the perimeter of the base times the height. So let's do it that way now and see if we get the same thing. So the perimeter of our base is, I'm going to go ahead and highlight that in, how about in red? The base is right here. Highlight that in red. So the perimeter is going to equal 10 plus 10 plus 6 plus 6. So what do we get? 10 plus 10 is 20 plus 12. So 20 plus 12 is 32. So the perimeter is 32. And then what's the height? Remember, it's the height of our prism, which is 12. So then we're going to take the perimeter. The lateral area equals the perimeter times, take the perimeter, 32 times the height, and we get 384 centimeters squared because we're talking about lateral area. So same answer, but two different ways. And I just wanted to give you guys two different ways of looking at this and using whatever makes more sense to you. So one way of finding the lateral area is just to find the area of each lateral face, add them all together. The second way is using this formula that lateral area equals the perimeter of the base times the height. So now let's take what we learned about lateral area. So we're focusing on how to find the lateral area, but now let's add in the bases. So remember our bases here we've kind of been ignoring. Let's add those in so that we can find the formula to find the surface area now. So the surface area is going to include the lateral area plus the area of our bases. So it was important that we learned how to find the lateral area because if you look right here, here's our surface area formula. So surface area, we find the lateral area and then it says plus 2b. Well, what does b represent? We know LA is lateral area. But what does that capital B represent? That represents the area of the bases. So the area of the base. Area of the base, not bases, area of the base. Because we're going to take 2 times B, that will encompass both of those. So capital B is the area of the base. So let's go ahead and continue working on this same prism. This is the same prism from the previous slide. It has the same dimensions. We know we already found the lateral area, that it was 384. So let's go ahead now and continue working and find the surface area. So in order to find the surface area, we have to find the capital B, which is the area of the base. And this is where it comes in. It's important that we know what the shape of the base is so that we can use the correct formula to find the area of the base. In this case, our base was a rectangle, so we know it's base times height. So we're going to take 10 times 6, which equals 60 centimeters squared. So now we're going to use the formula SA, surface area equals the lateral area plus 2 times the area of each base. So the lateral area is 384 plus, we know 2 times capital B, our capital B was 60. So let's do the math. 2 times 60 is 120, so I'm taking 384 plus 120 to get my grand total of 504. Surface area, our units are going to be squared. Our units of measurement will be squared. So there we go. So you can see how we built up to this. We had to understand what lateral area is and how to find it, which is what we did on the previous slide. And then we used that lateral area to find the overall surface area. Another way you could do it is just to simply find the area of each of our faces and add them all together, or you can use this very helpful formula. Going on to the next slide. So lateral area again is the perimeter of the base. Remember, lateral area is the perimeter of the base times the height. So it's important in this case, if we were going to find the area, the lateral area of this figure, that we know we're dealing with a triangular base right now, and that we remember how to find the area of a triangle. I'm going to skip this just so that we can go to volume. And then I'm going to call this recording. We're going to stop it before it gets too long. Volume of prisms is actually a lot easier than surface area. So that's the good news, is you've done the hardest stuff first. So the volume is capital B, which remember capital B is always going to be the area of the base. That's what the capital B represents. And H is always going to be the height of the prism. Oops. H equals height of prism. So it's important that we know what these variables represent in order to use them. So let's go ahead and find the volume of this prism. We already found the surface area, so let's not stop now. So let's calculate the B, the area of the base. We already did that. It's a rectangle, 10 times 6, which is 60. And now the height is 12. We know this is the height. So to find the volume, we're simply going to take the area of the base and multiply it times the height. So the area of the base is 60. I'm going to substitute that underneath for the capital B. And then the height is 12. So I'm going to now plug into my calculator 60 times 12, and I get 720. Now volume, our units of measurement are always going to be cubed. When we talk about volume, our units of measurement will always be cubed. For surface area, our units of measurement will always be squared. So I'm going to stop now, and I'm going to let you explore how to find the surface area and volume of all the other shapes we talked about in this week's lessons. One thing I want you to remember, though, is the difference between slant height and height when you're dealing with pyramids. That is an important, so you're going to learn about cylinders, you're going to learn about pyramids, and remember the difference between the slant height and the height is very important with pyramids, as well as with cones. So that is a wrap. Let me put up the key phrase question. Okay, as I mentioned, that there is a difference between slant height and height, and it's very important that we know the difference between the two. So I want you to explain, based on what I taught you in this recording, what is the difference between the slant height and the height. So again, I want you to use what you learned from this recording, and that should be in your answer. And that's it. The directions, if you need a reminder of how to complete the key phrase assignment, are below. Otherwise, have a fantastic rest of your week, and let me know if you have any questions.